Hey everyone, so today we're going to go over some practice problems related to Newton's third law. Now for the first problem, we have if Josh, who has a mass of 55 kilograms, pushes against Sarah, who has a mass of 75 kilograms with a force of 700 newtons, what force will Sarah exert on Josh and what is the acceleration of each person? So first let's draw this out. We have Josh over there. And we have Sarah over here. Now if Josh pushes on Sarah with a force of 700 newtons, what force will Sarah exert back on Josh? Now according to Newton's third law, every action has an equal and opposite reaction. So since Josh is pushing 700 newtons east, Sarah will have a force of 700 newtons west acting on Josh as a result of Newton's third law. And now that we have that, what will the acceleration of each person be? Now, despite their forces exerted on each other being the same, the acceleration will be different due to different masses. Josh has a mass of 55 kilograms, and Sarah has a mass of 75 kilograms. So we can expect Josh's acceleration to be more than Sarah's. But let's calculate this. We have force is equal to mass times acceleration. First, let's calculate it for Josh. We have force over mass is equal to acceleration. We have 700 newtons over 55 kilograms equal to 12.73 meters per second squared. That's Josh acceleration. And then if we do it for Sarah, we'll have force is equal to mass times acceleration. Force over mass equal to acceleration. And then we have 700 newtons over 75 kilograms equal to 9.33 meters per second squared. So as you can see, because Josh's mass is lighter or lower than Sarah's mass, his acceleration is higher. Now let's try the next problem. A book with a mass of 2 kilograms is resting on a table. What are the forces acting on the table and the book? So first, let's draw this out. We can draw out the book first, 2 kilograms. And then we can have it acting on a table. Now, if we go back to our force formula, F is equal to mass times acceleration. What could our acceleration value be here? Now, since the force will be acting downwards, our acceleration will be gravity. And G is equal to 9.81 meters per second squared. So F is equal to ma. F is equal to 2 kilograms times 9.81 meters per second squared. F is equal to 19.62 newtons, and we can round that to 19.6 newtons. So the book is going to have a force of 19.6 newtons going downwards, and according to Newton's third law, every force has an equal and opposite, or every action has an equal and opposite reaction. The table is going to exert 19.6 newtons back at the book. So they each exert 19.6 newtons on each other.